All right, as we're looking at this second part. Question, Katie?
Can I ask a question?
Sure. All right, we've got this equation again, same equation. And I've got a common difference, D, at the back. So each of these two equations, example 8 and example 9, are examples we're going to try to identify a couple things. First of all, just learning a little bit here. You see this negative 9? What does that number represent? The first term. So I'm asked to find the sixth term. So I'm going to put 6 blanks. 1, 2, 3, 4, 5, 6. I'm going to stick a negative 9 in that first blank. Why is it negative 9? The formula tells me. Negative 9 from right there. Now what else can I pull from this formula? What other information?
4.
Okay, what is 4? Okay.
Is the 6 number?
So that's the common difference. That 4. So what's negative 9 plus 4? Good, Scotty. Negative 5. What's negative 5 plus 4? Negative 1. Let's keep going. Plus 4. 3. Plus 4. 7. And finally, plus 4. 11. So there you go. You found, what's the answer? A of 6 equals 11. By putting a 6 in there, Cindy, what I'm saying is the sixth term. And notice this is a capital A. The sixth term is 11. Now that's all fine and dandy. But Barbara, if I said, find the 36th term, did this problem just become a little bit more difficult?
Yes.
Okay?
Could you just add, couldn't you times 11 times 6 or something?
Well, that's what I'm going to show you. Okay? Let's find the sixth term a different way, Kyle. Let's take the number 6 and let's put it into the formula. 6 minus 1 times 4. So I replaced the variable n with 6. Think with me. What's 6 minus 1? 6 minus 1 is 5. Okay? So that gives me negative 9 plus 5 times 4. What's 5 times 4? 20. That gives me negative 9 plus 20. What's negative 9 plus 20? 11. Do I get the same answer? Yeah. Algebraic method. Okay? Pattern method. Which is better? Sometimes. Do you always have to do the algebraic method, though?
No.
Now, could you, if I asked you to find the 36th term, make the whole pattern of 36 numbers? Yeah, you could have. But this is always going to work. The pattern method is sometimes going to be convenient. Katie?
Where did you get the 6?
Where did I get the 6 from? We're asked to find the 6th term.
Okay.
All right, so let's go down here to the bottom one, example 9. John?
What's the A?
The A just means arithmetic. So I named this function an arithmetic function. So instead of F like we had last week, now we're just using A. It's just a way to name a function. You know, your function, I would call it the J function for John. That's all. Nate?
Okay, for example 9, we start out with our first term is 2.
Well, that's a good point, but you know what I want to do? I want to jump right to the formula. So I want to find the 9th term using the formula.
Oh.
So here's what we're going to do. You are correct. The first term is 2. 2. Now in place of that n, what am I going to stick in? A 9. So 9 minus 1 times 10. Well, we can do this in our heads almost. What's 9 minus 1? 8. And what's 8 times 10? 80. So the 9th term is 82. Now, could you have put in blank, 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 all the way to 9 blanks? Yes. Would it have worked? How much would you add each time? What's the common difference? 10. You'd add 10 plus 10 plus 10 plus 10. That would have worked. And that's great, but it's a lot easier to do this. Now, this is the easiest question we're going to have today. Given this equation up here, What is the first term? Raise your hand if you know what the first term is. Okay, look at the equation. Remember, key in right here. That is what? 2. So what's the first term? 2. If they ever ask you what the first term is, there should be no work involved. None. So let's look down at example 10. Before we even get to the question, I want to ask a different question. Everybody write down what the first term is for example 10. Don't say it. Write it down. What is the first term for example 10? Raise your hand if you know. Moreno? Boom. Done. Okay? Should that be a hard question? You have to look at the problem, and you have to be able to pull out that information. Now, what is the common difference? Second question. What is the common difference of that equation? Moreno again. -2. Okay? He's pulling it out from right here. Now, I'm not going to do the blank, 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 blank method. I'm going to actually do the formula method. So the fifth term, 15, 5 minus 1 times -2.
I don't want to do it.
Okay? That's 4 times -2. That's -8. And what's my final answer?
-7.
Positive 7. Positive, because the 15 is bigger.
Oh, yeah.
Okay? So, positive 7. Could you have done the blank method? In this case, because it's a -2, Sarah, they would have gone down by 2 each time, not up by 2. So, in this case, it works to do either method. But could I have just as easily asked you for the 50th term? Would it have been any more difficult? Shouldn't have been. So as we're working through this, hopefully we've got a fairly significant and simple way to go through it. Come back to your formula up at the top here. Whatever the number is right here, that's the number of term they want you to find, Hunter. Here's the first term, and here's the common difference. So understanding that formula is going to be key as we kind of look through all